Hello everyone, my name is Sundara Swani Didde, and I'm here to present our project on legal case recommendation system with my teammate Jeet Ashwin Shah. So this project integrates advanced natural language processing techniques and a scalable cloud-based infrastructure provided legal case recommendation based on semantic queries. So let's dive into the components, architecture, and the impact on this system. So, this is a slight overview that our presentation is going to cover. So, the primary goal of this project was to create a recommendation system that simplifies the retrieval of legal cases by analyzing queries semantically. The system is designed to handle large scale workloads while ensuring seamless user interaction through a user friendly interface, obviously. So this is done by leveraging the Google Cloud platform. The project demonstrates modern deployment strategies with scalability and efficiency at the forefront. So let's talk about the software and hardware components. The system comprises of several backend components such as Fast API, Sentence Transformer, as well as the Google Firestore. So the metadata is stored in the Firestore while the embeddings are hosted on Google Cloud Storage. The front end leverages Streamlit to provide a web based interface. Google Cloud Run ensures the scalable deployment while PubSub manages asynchronous logging for query analytics. So let's see the architecture. So this is the architecture designed to ensure modularity and scalability. So users interact with Streamlit, which is the front end, which sends queries to the backend, which is hosted on Cloud Run. The backend then processes these queries by fetching embeddings from cloud storage and the metadata from Firestore. These recommendations are computed using the cosine similarity. PubSub logs each query asynchronously for future analytics. This entire system is orchestrated to handle high traffic and ensure low latency with the help of load balancers. So, as we talked about our architecture, I'm just going to give you a little more on the interaction of components. So, this architecture gives us seamless interaction. The front end sends users to the query to the back end, sends user queries to the backend, and Firestore, which fetches the metadata, and Cloud Run to retrieve word embeddings. The transformer processes these queries using the cosine similarity, and it calculates the similarity score and sends back the recommended cases, while the pub subcomponent is used to asynchronously log queries, enabling future analytics. Each component plays a really important role and for ensuring the system operates efficiently and reliably.
So I'm going to talk about the debugging and testing mechanism. We have the debugging and testing were integral to build a reliable system. We used Cloud Run logs and Streamlit error messages for real-time issue tracking, unit test validating, and backend endpoints while stress testing, ensuring the system could handle multiple stimulations of requests and end-to-end test verified smooth interaction across components from front end to back end, you can say. And then I'm gonna talk about the demo. Be showing you how our code works. Demonstration of my of our legal case recommendation system. And over here, you can see in the front end we can have two places where we can give inputs. That is the legal query that we want. Let's say we want to know about voting rights. If there are any cases related to that in the past, and let's say we just want three recommendations, and we'll just click on get recommendations. The front end will go, it will fetch the recommendations and will reply it back to us. This is how the three recommendation will look like. We are going to get the case name, we are going to get similarity score, we are going to get the code in which it happened, and the date it was filed in. So let's see just about this. And over here we even get the link to the URL. When we press on it, we can look into the details more. We can look more into the details about the case and learn more about it. So yeah, and to see what kind of services that we ran the code on G Cloud service, and like we saw the front end working on this link, which it can be accessed by anyone anywhere. And this is backend. We can even use legal backend service without even interacting with the front end using the curl command and giving it the requisite inputs. So let's go into the potential bottleneck. So we saw the demonstration right now, and now we're going to talk about the potential bottleneck that we have in the system. So there are three potential bottleneck right now which we do have. One is load balancer. So if there could have been a misconfiguration, it could live into an uneven traffic. Second would be the firestore query limits. Since if we increase the metadata size even more, it will take more time for it to generate, like to reply back. And even embedding size would increase if the data set is more, and it will cause a little bit trouble, and it will make the system slower. So yeah, let's dive into the future and some the summary and the future enhancement that we can have. The legal case recommendation system successfully demonstrates the integration of NLP with scalable cloud infrastructure, and future enhancement include fine-tuned models with domain-specific legal data, introducing query suggestions, and user authentication for personal uh, for personalized recommendation. Additionally, we can even add a cache system like Redis, so that let's say if somebody already searched for a particular thing, they can the it can go back to we can store that in the database and make the system faster by just retrieving that. And yeah, the data can be futurely scalable by using Kubernetes instead of Cloud Run. Yep, that's it. Thank you.